younger than her when that happened.
Okay, there we go.
I can check it. You need to jump into your
Any steps for you?
I can't remember where they are. But yes, there's a whole set of settings where you can do brightness. And I thought it was in this.
Well, the eyepieces Mommy has at home was $2,000. So eyepieces are expensive.
The bigger worry, though, is just that I think somebody did touch it because when I was losing
that's Zoom.
it wasn't there.
Right?
I think somebody jostled it a little bit.
Yeah, I can't remember, do you?
Because I remember you showed me how to do that.
Yeah. Well, just you'll have to just kind of play around with it.
Yeah, sure.
That's why we're kind of rushing to get everything kind of set up right.
Should I do auto exposure?
Yeah, do it.
What about gain?
And is it? Yeah, that's also autos, I think.
Oh no. No.
Hey, everybody in the plaza, how you doing tonight? Good, good. Hey, you've seen us. Hi, everybody. Hey, my name is Rick Alling, and I'm the manager of community outreach for the School of Earth and Space Exploration at Arizona State University. The main campus at Arizona State University is in Tempe, Arizona, and I'm going to try to be specific because I think we have a lot of guests that might be signing in from around the country and maybe even around the world. So Arizona State University, main campus, Tempe, Arizona. It's a suburb of Phoenix and kind of in the Phoenix Metroplex, but just outside of Phoenix, just a little bit towards the northeast, about 15, 20 miles, is a little community called Fountain Hills. Fountain Hills is a great place because it's about 800 feet higher than the valley where I live. It's also much, much darker, so they're further into the desert, and they're surrounded by, I'm sorry, look there. Okay, sorry about that. And so they're surrounded by mountains, and so they are blocked from the major city lights of Phoenix, Arizona. And that's really why we're broadcasting here. We decided to do this live, and we did it in communication with and in partnership with some people here at Fountain Hills, and I'll introduce them as we go along this evening. But for right now, I'm just glad to be on board, and I'm glad to be broadcasting, and I'm glad that you've decided to join us. Here's how the evening is going to go. So in just a moment, I'm going to introduce the first of 3 segments where we have some guest speakers that are going to tell us various things about the moon and about the activities here at Fountain Hills. In just a minute or two, I'm going to introduce the first one of those guests, and then we'll talk for about 15, 20 minutes. Then we're trying to organize, we've got it almost ready, a live view of the moon from Fountain Hills. And so we'll sort of cut back to that, and then in a couple minutes after that, we'll sort of go back to the second segment and then the third. So we're going to be broadcasting live from now, starting at 7 o'clock, until about 8:30. Now, here's the other thing. As I realize that there's some sort of disconnect in logic here. Tonight is International Observe the Moon Night. We've set it up so that you can sit in your living room and watch us instead of looking at the moon. That's a big mistake. We don't want to do that. So I will be giving you chances during the evening as we kind of go through, as we cut away from some of the guests we have. The real idea is for you to get out of your house, go out, get into the night sky, and look at the moon. It is a waxing crescent. I had to think that through for a little bit. It'll be a half moon in a day or two, and so it's absolutely stunningly beautiful in our telescopes because of the way the light glances off the surface of the moon. We can see really beautiful deep cratering on that area between the light part and the dark part. We call that a terminus. So who knew somebody would come up with an International Observe the Moon Night, and tonight's the night, and this is how we're celebrating. So welcome aboard. I'm going to introduce a gentleman here. His name is Chris Luna, and seriously, that is his real name. So, and Chris actually works at the Arizona State University campus for a center. It's called the Lunar Reconnaissance Orbiter Camera. And so he'll explain a little bit more about that, but there is an ongoing mission. It's been orbiting the moon for over 13 years now, or just about 13 years. And at ASU, we run a suite of cameras. And so I'm going to invite Chris to the table here. We'll introduce him again, let him tell you exactly what he does with the Lunar Reconnaissance Orbiter Camera, and we'll see where we go from there. Hey, Chris, how you doing? Thank you very much for coming. Oh, everybody's laughing. I forget we have a live audience. Go for it.
Yeah, thanks for having me. It's good to be here on International Observe the Moon Night.
What were you doing a year ago on International Observe the Moon Night?
I was probably observing the moon, yeah.
Okay, were you? Okay, excellent, good. So tell me what you do for LROC is what we call it. So if I use that sort of acronym, sorry about acronyms, but if I use LROC, that means Lunar Reconnaissance Orbiter Camera. What do you do for LROC?
So I am, my technical term is research analyst at LROC. That means, for me, I am a satellite instrument operator. So. Okay. My job is to build command loads for the satellite camera to take of the moon.
So you're building the information, sending it the instructions on what it's supposed to do?
Yeah, so right? we actually work with Goddard Space Flight Facility in Maryland. Okay. And they will basically sign off on the commands that we build for our camera instrument. And we have to be very careful because occasionally, commanding this satellite to, we call it slew. So slew means just like turn on its axis one way or another. Could cause the satellite to look, put the camera pointing towards the sun or putting the solar array that powers the satellite off the sun for too long. So those are things that we have to navigate around.
So is it simple to say, so somebody else is driving the satellite, right, the actual spacecraft. Your job is to control the cameras, and the coordination is because the cameras can throw the spacecraft off if you're not careful.
Yeah, damage to the spacecraft or damage to the cameras due to sun exposure or temperatures.
Was I right about the duration here? Is it really about 13 years? Is that what we have?
Yeah, I believe so. That's correct.
I think that's it. And
I want to say 2009, 2008. 2009.
2009, that's it. And one of our colleagues, I know she's watching tonight, Meg Hufford, you see her on some of our other broadcasts. She was actually at the launch. I'm jealous. I've never been to a launch before, but she was there, and she would remember. And then I think I just want the audience to know that space missions like this, they have a duration. There is there's an objective, there's a science objective, and there's a duration of time given to that science objective. And then when they get close to completing that, we can go for extensions. And if I understand this correctly, this particular camera, these instruments are actually on their 4th or 5th or 6th extension because they're working so well. They're still delivering science. And as long as everything's running, they took their 18-month mission and turned it into almost 13 years. Is that right?
Yeah. So if I'm, based in the past week in our financial calendar, I believe we just entered a new fiscal year for our department. And so with that, we concluded extended mission phase 4, and we're moving into extended mission phase 5.
No, excellent. Okay, I had that almost right. I sort of have to do this from memory, and but I think that's absolutely amazing. And I think the fact that we actually operate these cameras, it is the control center for this particular part of the mission, is actually on the ASU campus in Tempe, and has always been. And so that's pretty cool. Can I switch gears a little bit now? One of the things that we're going to be talking to, or we were talking to LROC about a couple of weeks ago, is just sort of this explosion of missions to the moon. And so what's the future for the LROC camera, the ones you work on? What's its new thing? And then you and I can kind of get into talking about some other things we're looking forward to.
Sure. So one of the things that we were focusing on is that, has always been part of LROC, is imaging intensely areas of future landings.
Okay.
So every so often, some space-oriented entity or even businesses approach LROC and say, hey, we would like this particular area of the moon targeted because we want to send a lander there. And so that's one of the things that we've been doing and we'll continue to do as we move into ESM5, this extended science mission program. And then, so that's with LROC. But something we're also doing with upcoming missions, and the upcoming missions we'll focus on, is areas on the moon that have maybe a water ice or other volatiles that we're interested in. And so the LROC team is helping, and we're working with the Korean Space Agency to do shadow cam, which is a totally separate project, but will be run by LROC to image areas of the moon that are permanently shadowed.
It looks like the team has the image of the moon up on the screen here. So
that's great.
So we have a live camera. This is what it looks like from Fountain Hills, Arizona. So if anybody's watching from someplace else that is all clouded over tonight, you sort of you can kind of just tune into us and see where that goes. So shadow cam, and so we watched this launch, and it's on its way to the moon right now.
Yeah.
So this is a Korean spacecraft called KPLO, and if I remember right, we made a deal, so U.S. and Korea, and they were able to use our launch facilities and some other amenities that we have that they don't, and then they offered to let somebody from the U.S. propose a camera or a device, an instrument, and so your team came up with shadow cam. And it won, right? I mean, this is a selection process. Not everybody gets to do this. And so you won camera on board. It's going to arrive at the moon, I think, in December. Is that right?
Yeah, somewhere around the new year.
Somewhere around the new year. And then we should be seeing science from it within about the next month or so, if I remember the right. And this is just a very, very high sensitivity camera. It's kind of, we call that legacy from some of the cameras you already have on board. But this one has a much more sensitivity, and we'll be able to see into those permanently shadowed regions, right into the dark craters. Is that right? Is that what we do? Are you going to work on that one too? You get to do that too?
Yeah.
Okay, all right.
So right now, this is, we're currently working on making sure everything. So we have a protocol in place for taking images with the LROC camera, of the moon.
And been doing that for a decade.
Yeah, regions of interest on the moon.
Okay.
So what we're working on now is making sure that we have we're basically taking our protocol that we know works for LROC and, modifying it with everything, all this, details that pertain to shadow cam, and making sure that we have an existing protocol that works. That way when shadow cam, KPLO, when it gets to the moon, everything's in place. We can start imaging right away on time and without a hitch.
I think that's excellent.
Yeah.
And everything seems to be working so far. If I remember right, it
Yeah.
got launched, it's communicating, it's talking to you.
Yeah, we're very excited about that.
With whatever checkouts you can do, because you don't have a target yet, but it seems to be working. This is one that works.
Yeah.
That's great. Well, that's excellent. Can I just also tell everybody this is a mission that is on its way, and it's there. ASU also has a mission, and it's not associated with the LROC Center, but another group, Dr. Craig Hargrove, has put together a spacecraft that is basically a neutron, a gamma ray neutron detector, and it is on board the Artemis 1 rocket. So Artemis 1, not to get too complicated here, but Artemis 1 is a huge rocket about the size of or bigger than the Saturn V's. Artemis 1 was supposed to launch about a month or so ago. It was rescheduled for about last week, and then with the hurricane that hit Florida, it had to get pushed off again. So they basically took it off the pad, loaded it back into the facility, and now it's waiting for new launch instructions. We're hoping to get that off in November. So here's another ASU spacecraft that just basically is sitting there in Florida. It's waiting for its ride. That should be coming up, and I want everybody to watch for this, because when Artemis 1 launches, that's an important mission on its own. It's preparing us to send people back to the moon, but ASU has an app, and so it will be basically looking for this water again. So this is kind of the big interest, water on the moon. Have we known for a long time there's water on the moon, or is this fairly new?
I think, it has been theorized for a long time, and I think as far as hard evidence, we have like laser, what is it, what is it?
I think
spectroscopy?
Yes, exactly, yeah.
Yeah, based on those observations, we can say there should be, some volatile here. And so the idea to get a physical sample and analyze it would be to confirm all those kind of remote sensing, methodologies.
And both of these missions at the same time, and they're both using different technologies, right? And they're going to get different parts of data, and kind of putting all this together. Essentially, the goal here is to map how much and how it is distributed, and how that water operates on the moon, and where that goes. I think that's absolutely amazing. That's super cool. Can you, LROC also in its recent history and past history, and I've kind of looked through your website and I've talked to your people quite a little bit, but can you tell me a little bit about the mapping of the Apollo sites, right? Each of the landing sites for the Apollo missions have now been remapped by you guys. Is that correct?
Yeah, so it's a pretty standard procedure. So we have basically a region of interest that we'd like to target. And for Apollo, that's being a legacy and of human activity on the moon. That was probably one of the first primary regions of interest that we had in the beginning of the mission. And there was a lot of, basically what our satellite is doing is orbiting around the moon. It kind of does a slight deviation of the path every time it goes over.
Right.
So the orbits are continually moving eastwards or westwards, depending on whichever way the satellite is going. So with that being said, when it comes to Apollo or any other region of interest, we'll hit it at a certain incidence, which means like what the angle of the sun is, whatever the angle of the sun is, whether the tilting of the moon. And so we've been able to image Apollo over a wide array of incidences, and rebuild this kind of map of what had happened there.
I think it's fascinating stuff, and every time I see some of your work and your maps, it's really something to be proud of. It is really stunning. LROC also, for you guys, anybody watching, sort of around the nation, around the world, or the people here at Fountain Hills, LROC has this really wonderful website. So if you just ever want to just go visit what they're doing, see what they're doing, there's another thing that they do that is very popular. Is they map the same area over and over again, and they look for new cratering. And so they can do this, and then basically we understand the amount of actual cratering that's continuing to happen on the moon even today. And then the website is set up so you have this little slider. You can go from before and after and before and after, and these craters just sort of appear, in the time sequence. And that's really kind of fascinating too.
Yeah, there's two past incidences recently. First was January 19th eclipse event. I think that was within the past 3 years.
Yep.
There was an impact on the moon during that event.
Oh, while you were actually watching.
Yeah,
Okay,
and so, you know, I guess people who were observing the moon during that eclipse actually saw like a puff or something come off the moon, or a flash, and that was kind of a manhunt to use
absolutely.
to re-image that area and find, you know, this new crater that just happened. And then more recently, there was a booster from a different space agency that impacted the moon, and that was known that it was going to impact, and so we had to go. We were kind of asked to use our orbits up to try to image this wide area. And then once we had the images, people went and sifted through the images for hours and hours and hours.
And then finally found this.
And then they finally found it, yeah.
So you're nimble enough that somebody can make a request, and here comes something, it's in this amount of time, you can actually get your satellite to that place?
Yeah, well, it
it's
takes...
probably even more harder than that, but...
Well,
right?
no, it takes time to get to that location because it's like a predetermined east or westward movement.
Right.
But once you're there, you know, just point your camera at the same spot on every orbit and hope you get something.
I think it's amazing.
Hope you find it.
I don't know. I've been around for a long time, and I've talked to you guys for a long time, but I just still think it's fascinating that you can actually sort of call up, order up photography, right? We want to be here at this certain time. We want to get this particular angle, all of that kind of stuff. You guys can then do the magic that gets the spacecraft into the right place at the right time to take a picture, and I think that's fascinating.
Some of it is a waiting game, like especially in the polar regions. We have a lot of issues with if we want to hit an exact certain spot, there's a chance that we're going to get the sun into the...
Yep.
There's a cone that we can't let the sun enter to the camera because it'll damage it.
Okay.
So there's we have to be careful around the poles because there's a bigger chance that we will actually, in tilting the camera, expose it to too much sun.
I see.
And so that's, we call that solar occultation.
That would kind of put you out of business.
Yeah,
right? You can't look at the sun.
We actually have a protocol for that. It's called sun-safe mode, where
Okay.
the instrument protects itself so that
So it'll shut itself off.
it
It'll
basically
sort of-
protects itself from overexposure. But luckily, I don't think I've ever put the camera into sun-safe mode, but it has happened.
It's probably not a badge of honor.
No.
Steer it into the wrong place.
Yeah.
It's absolutely amazing, absolutely fascinating. And so I just kind of wanted to just kind of get everybody sort of on board now. Let me sort of just repeat some of the things we talked about when we started the broadcast. We're doing 3 segments with different guests. Chris Luna is with us right now, and Chris is with Lunar Reconnaissance Orbiter Camera, which is a center that operates literally an instrument, or actually this is 2 wide angles and 1 narrow angle?
Two narrows and 1 wide.
Okay,
angle.
I had it backwards.
Yeah.
And so there are still 3 cameras operating today.
Yes.
Right? And all of them kind of work together to do that. I think that's great. And so Chris works for that particular team. How long have you been with them?
I've been with them since December 2018.
2018. Okay, so that's pretty recent. Almost 4 years now. Oh, that's excellent. Very, very cool. They're always doing something amazing, and I really appreciate having them sort of next door. We are, both of us are based on the ASU campus. I operate out of a building called ISTB4, and it's the headquarters of the School of Earth and Space Exploration, which is the geosciences and the astrosciences kind of in the same school. And we have a fairly robust public outreach program. People can come visit us on campus. We have programming. We have a very special 3D immersive theater that we run on the ASU campus. And so if you're ever in Phoenix and if you're ever dropping by, and if you're doing so, make sure you stop by and see us. LROC is actually across campus. It's about a, 10, 12-minute walk from me, and they have a visiting facility as themselves. And I think on display in your little gallery area is a moon rock, if I remember right.
Yeah, we have a moon rock from one of the Apollo missions.
Not everybody can say that.
Yeah.
Not everybody can say not everybody can say they've ever seen a moon rock before. So again, one of our reasons for getting out and just making sure everybody knows what's going on is that Arizona State University is really very, very big in space and in planetary research and geological science of planetary surfaces. And so all of this relates to those areas of interest. And Chris Luna, thank you very, very much for joining us. Anything else you want to say to everybody before you go?
Enjoy the moon. It's, it's not, sometimes we have new moons, so it's hard to see it, but tonight's not one of those nights, so.
Is it your favorite astronomical object?
Well, my name is Chris Luna, so
It had to be, yes.
yeah, it's got to be.
So just real quickly, I want to mention that Scott Snell from the LRO flight software team is actually in chat and wishing everyone hello from the LRO team at Goddard. So they're just saying hi.
Oh, excellent. And so what was his name again?
Scott Snell.
Scott Snell, I guess, is visiting, and so he's at Goddard, and he works on the orbiter. Is that correct?
Yeah.
Anyway, he's saying hi to everybody, and so I guess they're tuned in and they're watching and they're seeing what we have to talk about tonight. So, and not only to them, but anybody that has found their way to this broadcast. I'll try to repeat it, kind of as we go, because I know people are coming and going. But we're going to do a couple of these interview segments, and we're going to take little breaks, and that break is a chance for you to go outside and look at your own moon. We're not trying to keep you from doing that and enjoying your own moon activity, but we have one of those coming up. So we will be back at 7:30 our time. We're Pacific Daylight Time right now, and so that's just in about 6 or 7 minutes. And I have another guest from Fountain Hills. Scott Adams is going to be talking to us about some of his astrophotography and how he achieves his astrophotography and what he does and how he enjoys that kind of work as an amateur astronomer. So Chris, thank you so much for joining us. I think this is amazing. LROC has a table just right over there. I don't see the lights and they're waving over there. And so they're going to be here. They're passing out kind of little cool postcards and swag and all that stuff. So if you haven't had a chance to visit that table yet, for those of you that are live on site here, go see those guys and we'll see how this goes. All right, everybody. I'm going to kind of go offline for just a little bit. We'll be back with you at 7:30. Thank you.
Thank you.
All right, thanks.
Yeah, thank you so much.
Oh, look at that. You're enjoying this sort of fun. All right, everybody, welcome back. So if you're just joining us, or if you were here for the last segment and just continuing on with us, here's how this is going to work. During the evening, I'm going to just be doing some 3 different segments with guest speakers about different aspects of observing the moon. In a moment, I'm going to introduce a gentleman that does astrophotography, and we'll sort of see some of his slides, and he can explain to you all the secrets that he does to make those amazing images. I want to, before she gets too squirrely, I wanted to introduce you to my dog. Her name is Luna. I'll be darned. Hey, Luna. Can you say hi to everybody? Yeah, maybe not. So Luna has been on a broadcast that we do, and so if you've never seen us before, if you're joining for the first time, my name is Rick Alling, and I'm a manager of community outreach for the School of Earth and Space Exploration at Arizona State University. And then a couple of years ago, because of COVID, we couldn't have people come in, and we started producing this every other Wednesday night broadcast. So every other Wednesday, we're still doing it. Every other Wednesday at 7 o'clock, we get on. I have a great team of workers and students, people, my staff colleagues, and some students, and we cover different aspects about research and astronomy and exploration, and sometimes into cultural astronomy and observing and all of those kinds of things. And so it's one of those programs. Luna joins us every once in a while, and she's become the mascot of the program. So if you join us on every other Wednesday night, the next one is this coming Wednesday on October the 5th, and we're going to be talking about spectroscopy of Europa, a moon of Jupiter. So that'll be a good thing to come watch. But tonight the focus is, I'm going to let Luna go away. Tonight the focus is the moon. International Observe the Moon Night has been going on for many, many years now. We have found a way to do some sort of program just about every year. This year we decided to go live and broadcast from Fountain Hills, Arizona. So if you're just joining us now, we are at a plaza. It's called Centennial Plaza. It's in kind of the central region of Fountain Hills. Fountain Hills is a suburb of Phoenix. It's just far enough away, high enough, and hidden between mountains and us, so they have a dark sky designation. And in about a half an hour, you're going to meet the team and some members that actually help put that together, and you're going to learn some of their plans for the future with this dark sky designation next to a really huge metropolitan area of Phoenix, Arizona. So we have left the campus. We're up here now, and we're kind of doing a little program up here. Without any further ado, we wanted to do the middle segment on astrophotography. So I'm going to ask Scott Adams to come to my table here and join me. Go ahead, Scott. Everybody in the audience here, you can clap now. That would be all right. Yay! See, I told you we were live. So Scott is just a member. So you'll have to tell me that your membership. So you're with the Dark Sky Club, right? And,
yeah, I'm with the Fountain Hills Dark Sky Association.
Okay.
And I'm the past president of that organization, and then I'm also on the board of directors of the International Dark Sky Discovery Center, which you'll hear about later on this evening.
Okay, so there's an association of people like you, residents, that got together, and you guys are all volunteer, right?
Right.
And
exactly right.
Tell us just really briefly about sort of when and how long it took, and what did it take to get a dark sky designation here at Fountain Hills?
It took maybe a year and a half, 2 years, and Joe and Nancy Bill, who will be on later, will talk about that in more detail. But in summary, the process was to just apply to the International Dark Sky Association in Tucson and get the town council to agree to certain changes in their lighting ordinances to prevent light from being directed upward into the sky, essentially, and we have to maintain certain standards, file an annual report, and so forth to keep that designation.
And you're not the first, but maybe you're maybe one of the latest. And these, there are places around the country. Flagstaff, Arizona was the first, if I remember right. And now many national monuments, many national parks, many places sort of that realize how special their place is because of controlling light are taking on this particular thing. And I applaud you and your team and your group for doing that. But that's not why I invited you.
Thank you, and thank you for coming to Fountain Hills.
Oh, thank you. So that's great. No, we want to see some of your images. So how long have you been interested in astrophotography? And Alex, we have a delay here, so we're probably not going to be able to see what you're seeing, but we'll go ahead and sort of start anyway.
Yeah. Before the first image comes up, I'll just say that I retired to rural Colorado in 2006, where the sky was much darker than it is here. But it took me 9 years to realize, to really catch on and say, I need to get a telescope.
Okay.
And I don't know why that took so long, but anyway, in 2018, my wife and I moved here to Fountain Hills because we have family in the area. And I guess it was a couple of years after that that I started thinking, well, gosh, if I just put a camera on a telescope, maybe I can take some pictures. And so I think if the audience is seeing this image on the right, that's the size. It's a hobby telescope. It's not anything professional. It's just a 6-inch telescope. And there isn't a camera in that picture, but I put a DSLR camera on the back of that one to start with. And I started taking pictures of the easiest target in the sky, the moon. It's real easy to find, and you can make excellent pictures of the moon with a DSLR camera.
Excellent. And this rig is right here today. I think I saw it over there, right? You
that's
brought
a
it up.
different one.
It's a different one. And, and then the trick here is it looks like there's a really, really good tracking mount. There's a motor that makes it move with the curvature of the Earth, and that's really important for astrophotography.
It is.
Yeah, so
It's got to be able to follow the objects in the sky as in their apparent
just
motion.
as precisely as you possibly can.
Yeah.
So really, you were saying this is like a hobby-sized telescope, but the real money here is in the mount and the tripod, the making it just sort of as firm as it can be.
That's
tracking
correct.
correctly. Yeah,
But
so.
with the qualification that for lunar photography, this isn't really the right mount for serious astrophotography. But this is perfect for lunar photography because my exposures of the moon are on the order of a 400th of a second.
Oh, okay.
So it doesn't matter.
That's right. Let's go ahead and cycle through. Let's see some of these images. I
Let's
can't
see
wait
what
to
else we've got.
See what you have. And so, oh, okay. So we have a first image up here, and unfortunately we just have a little bit of a delay, so we can't see which one's up now. Let me see. There you go.
Yeah. Okay. So yeah, that's just a pretty typical picture. It's not a full moon, and it actually I think makes a better photograph than a full moon photo because along that termination line that Rick talked about earlier, you can see much more detail in the craters. The shadows of the craters show up, and so you get much more texture in a photo like this. But one other thing I should probably say is that this isn't just a single photo. I usually take anywhere from 50 to 100 photographs of the moon, and then I sum them together in Photoshop or other programs on the computer.
Do you have a special? We call that stacking, right?
Yeah.
Do you have a special stacking program that you prefer?
I use Deep Sky Stacker.
Okay.
It's a free download, and for my lunar photographs, that's what I've used. I now use for deep space objects, I use a program called Affinity, which is similar to Photoshop, but it doesn't really matter. Deep Sky Stacker is an excellent stacking program.
I'm glad there's people like you figuring this stuff out, so I can just follow your advice. Right? So,
Yeah.
So this is perfect, Scott.
It's taken a while to learn it.
And so, and on this one, so again, just sort of recapping that. So, just because I know a lot of people are watching that might not understand this technology, but you take multiple images, and then there's a processing way where the computer actually marries those images together and stacks them, and so gives it is a way to bring out more and more detail and more stuff. But there's a lot of then post. I mean, it takes whatever 20 minutes to take the images, and then half a day to like put it together.
Maybe not quite a half a day, but a couple of hours.
A couple of hours to sort of like make that happen.
To put it together. And the reason for stacking is to reduce the noise that's associated with the photos, because there's a lot of atmospheric turbulence and things like that. You know.
Okay, excellent. I get that. And then just again, so this is probably a waxing gibbous moon. So this is past a half. You see the very distinctive 3 C's up at the top, the dark spots, 1, 2, 3, kind of going from left to right. Those are C's called serenity, tranquility, and fertility. Tranquility, the one in the middle, is the famous one. That's where Apollo 11 landed. Remember, Tranquility Base. We're here. And so, but then this is not a full moon, and just doing that. So where the sun and the dark spot meet that's called the terminus, and that's a place where the sun is hitting the moon at a really, really severe angle. So if you heard our little discussion before with the LROC camera people, this is really important for their research too, is timing your images so that the sun is hitting just exactly at the right angle and bringing out the depth of all that material and stuff. When you look at a full moon, just flat on full, it's very, very bright. There's a lot of glare, and you don't get that shadowing that you get here. So that I can see why you picked this particular time and this particular moon. It's absolutely stunning. So go ahead, Alex, and
maybe since we have limited time, you can either go to an eclipse photo or the jet aircraft in front of the full moon. That's kind of a fun. Okay, that's a fun one. So yeah, I can talk about that one then. I was out in my cul-de-sac one evening just photographing the full moon, and the moon was not far above the horizon, and from where I live, the planes coming into Phoenix's Sky Harbor Airport are going from east to west, and I could see this jet. Looked like he was about the same elevation above the horizon as the moon, so I just waited, and I got really lucky and got one shot of the plane in front of the moon.
Now, do you know you could just Photoshop this in there, right?
Yeah,
but you didn't do that.
But I didn't. I promise I did not.
You promised. So this is absolutely an amazing image. And so, did you take multiple pictures and you caught this one, or did you just happen to get it at the right time?
I took more than 50 photographs of the moon, and I did my usual stacking that night, but only one of them had the plane.
Right, because it would move so fast, it would be gone by the time you're.
The one trick that I did on this photograph is since the heat trails behind the jet engines showed up only in that one photograph.
Oh, I see.
And stacking them, of course, eliminated that. But I wanted that to be there, so I used some tricks in Photoshop to recreate those. But it's not a fake photo. It's a real photo, a real jet at that instant.
Absolutely beautiful.
Yeah.
All right. What else do we have, Alex?
We might want to look at an eclipse. How much time do we have?
We got a couple of minutes, and so as the next image is coming up for us, so we can see it, we're going to get an eclipse image up. I just wanted to let the people here at Fountain Hills know that when we take a break here in just a couple of minutes, in about 3 or 4 minutes, we'll take a break, and Ted Blank is on site, and he's got a laser system, and we're going to spend 10 minutes showing you essentially around the night sky, not just the moon, but some of the other features that are up there. So if you give us about 3 or 4 minutes, we'll get off the air here in a minute, and then follow Ted Blank and his laser show. Then we'll be back on with another program after that. So okay, so what's this about?
So yeah, this was last May of this year, lunar eclipse, total lunar eclipse here in the Phoenix area, and I think I was up in the middle of the night maybe for this one. I can't remember exactly what time it was, but
I don't remember either.
Anyway,
absolutely, I did observe it.
The colors are just so beautiful. I love the orangish hue, and so it's a stack just like the other photographs, but in this case, a full moon looks really pretty because it's under eclipse.
Yeah. Absolutely beautiful, and you sort of get that reddening, right? So the science of the thing is, as the Earth's shadow is kind of passing in front of the moon, the atmosphere of the Earth actually bends the light from the sun. It kind of like focuses the red parts towards the moon, and the blue and green parts, you sort of know the rainbow, and it sort of scatters the blue and green kind of colors out into space. And so that's really why we have this really luscious blood red kind of or orangish moon here, is because it's sort of that it's an effect of actually the Earth's atmosphere projecting down to the moon, and it's really beautiful. Good job.
If we could go to just one more slide, it's the Galaxy slide, Messier 33, I think it's called. It's near the end, and that's a different type of astrophotography,
sure.
And I'll show you an example there.
And so this keeps you busy, right?
Yeah, it does.
And you always got something to look for,
yeah,
right? There's always another thing coming. Okay, we have it up now, so oops.
No, that's not it. But
I had to cycle a little bit.
yeah, there we go. Yeah, unfortunately, astrophotography I learned too late. It's a hobby that you have to stay up late for. It's a nighttime hobby.
Yeah.
But anyway, this type of a photograph, this is a galaxy. It's the second closest galaxy to Earth, and it's called the Triangulum Galaxy. And I just took this last night and the night before. I took 115 different 3-minute exposures using a mount that really tracks very, very accurately the movement of anything in the sky. which is really critical
For something like this,
to
I can
have
see
your
it.
camera on for 3 minutes.
Right.
And this is not a DSLR camera. This is an astronomical camera. Looks more like a Campbell's soup can,
Right.
and it's completely controlled from my cell phone.
Ah.
But anyway, it's just a fun thing. It's a really, really dim object, and it takes hours of computer processing to pull this type of a color image out of what you get initially from the camera. But it's not a fake color image, not a false color. It's real, but it's just so faint that it takes lots of work on the computer.
It has a lot of detail.
Yeah.
And it's actually sort of, it's prescient tonight that you shared this with us, because this was taken in Fountain Hills, Arizona.
Last
right?
night. Yeah,
Last night? Okay.
And the night before from my backyard.
So basically, this image taken from this community, and I think I explained to everybody just a little bit ago, Fountain Hills is a suburb of Phoenix. Phoenix is the 5th largest city in the country, in the United States now. And so to have this treasure, right, just very close to our community, you're going to learn a little bit more about that. The folks out here are trying to build themselves a little center, a Dark Skies Science Center and Exploration Center, and I think that's going to be great. What an asset for us, and to know that I can't do this from Central Phoenix. This won't work in my backyard, but 25, 30 minutes out of town, this is the kind of astrophotography we can get. I think it's amazing.
Yeah, it's fun. It's a lot of
Ted,
fun.
it's awesome, and thank you very much for first, kind of helping to put this together and host tonight's program. I think that's great, and thanks for sharing your astrophotography. This is wonderful.
Cheers, my pleasure, and
All
thanks
right,
again
thank
for
you.
coming, Rick.
I'm so glad you're here. Okay, we are, thank you. There's that audience again. You guys are spot on. So with all the lights, you guys could have all gone home, and I'd never know it. So I just want to say, here's how the next segments are going to run. We're going to take about a 10-minute break or so right now. For those of you here on site, hang on for just a second. Go find Ted Blank. Follow his laser. He's going to kind of give you a little scene. And then at 8 o'clock, is that right? 8:05, we're going to have another guest, Joe Bill, and he's from Fountain Hills here, and he's going to tell you about their plans for this Dark Skies Discovery Center. So now's a chance for you viewers online, go out and take a look at the moon. Take a little break, get a snack or a beverage, and come back and join us in about 15 minutes. Thank you, everybody. Hey, Joe, Bill, if you're around, can you make your way over here? Hey, Joe. Yeah, I guess we're gonna have to. See, working on something over here. I wasn't watching, but I was listening, and it sounds like you guys got a really great night sky tonight. And so all the characters, all the regular characters are there. Just if you're just joining us, if you haven't been following along, it is just a little bit after 8 o'clock. We're starting the third of 3 segments where I have an invited guest to kind of talk about things. In a moment, I'm going to introduce Joe Bill, and he's going to talk a little bit about the Dark Sky Discovery Center that is going to happen on this site as soon as they can get it organized and do some fundraising and get it going. And so we'll hear about that. In the meantime, I have been remiss in introducing everybody on the team. So I wanted to say that my name is Rick Alling. I am a manager of community outreach for the School of Earth and Space Exploration at Arizona State University. And we have a robust outreach program. We do a lot of things. And one of the ones is we've moved into some broadcasting. So we do a program every other Wednesday night. It's called Virtual Night Sky. And that's produced by us. Just the same kind of thing. We have subjects of interest about astronomy, of exploration, and we do those every night. The cameraman tonight is Alex Blanche. Alex is a senior at Arizona State University. He's an astrophysics major, and he also has been working in the community outreach program for many years now, and he's been a regular on the Virtual Night Sky team. And he joined me out here at Fountain Hills tonight to sort of do the International Observe the Moon Night. Also with me is another student, Maitreya Sonaway. He is also a student, and he's also an officer in an astronomy club. So students get the chance to use telescopes and deploy them and set them up around for outreach programs. And so he's interested in that. My wife and my dog are both here tonight. So Jackie, thanks for coming. And Luna was on the screen here just a little bit ago. I heard her barking in the background. So we're going to do this for about 15, 20 minutes. I got a little chat with Joe here. We're going to talk a little bit more about some things that we can see. For the local folks here, we're going to go back into some star gazing just after this particular program at about 8:20. And we intend to stay broadcasting at least the live view of the moon until about 8:30 tonight. So that's how we're going to recap. All right, next to me is a gentleman I met, I guess, about 2 or 3 years ago, I think. And we were talking to Scott Adams a little bit about your efforts to make Fountain Hills a dark sky community, and that happened, and that wasn't enough for you, was it? Right? So now it's time to build a science center. Is that the idea?
Yeah, who came up with that idea?
I don't know what's going on here.
Actually, we are so excited about what we are doing, Rick. First of all, we're very pleased we were able to get that dark sky designation so close to a major metropolitan area.
Oh yeah, and that last slide we went with Scott Adams. It says I'm here, I'm very close to my house, and here's a place where we still have that sky, and you guys set it up. It's here forever now, right?
We have relatively dark skies, and there's a hobbyist astronomer here named Charles Jules who discovered 400 new asteroids.
Oh my gosh!
And one of them is named Fountain Hills.
Okay.
So I hope it's not headed this way.
I hope that's not the one. Okay, good. No, so basically, so the new plans is, and I have to say selfishly here, Joe and my team and the outreach folks and some of the faculty and academics at the School of Earth and Space Exploration and other schools on campus are really in discussions about how we can actually work together, how their efforts can be a asset for ASU and ASU students, and they can use it for some of their learning as well. So we should talk about that, because you're not just here standalone. You're supposed to be partnering with a major university. Right?
That is correct. And I think that one of the things that you well know, and all these viewers probably know too, there's a problem with light pollution and how that adversely impacts astronomy. We want to try to open the window to the observable universe by trying to reduce light pollution as much as possible. So that really is that boils down to the mission of the facility that we are trying to create, because we want to educate people about smart lighting, And one of the things that a lot of folks maybe don't appreciate is that it's not just astronomy that's affected, but it's all life on Earth that's affected. It affects human health, nocturnal animals, nocturnal pollinators, bird migration, and I can go into those details if we want to talk about that. But that's what our mission is to kind of educate people about the problems with excessive artificial light at night.
You know, and I think this could be a model for other big cities too, right? I don't think it's reasonable that Central Phoenix is going to become dark sky. That doesn't seem right. And how many communities around the country, you know, are in that? You know, you're not going to do that. But to have a space not far away, I mean, just have a suburb, have a place that can take that on, and then people have access to a dark sky. That's something you can't duplicate. You can't fake that. It has to be a place, and it has to be a place like this to make it happen.
Exactly, and maybe I can describe the facility.
Yeah,
a little
please
bit.
do all the components, because there's some exciting things going.
Yeah, it's really Rick is really a unique facility in the world because under one roof we're going to have a domed observatory. We're calling it the Dark Sky Observatory. We will have a planetarium. We are calling it the Hyperspace Planetarium.
Okay.
And Inspiration Theater, because as you know, one of our jobs is to inspire the next generation.
Right.
That's what we want to do. And then an immersion zone, which is basically, it's going to be a highly interactive exhibit hall, educating people about all the aspects associated with light pollution and what's up in the sky and all kinds of things. So we're excited about that. And we even added another component just recently. It's called the Einstein Exploration Station. And it's going to teach it's going to focus on teaching the physics of light.
Okay, excellent. And light in astrophysics, it's kind of everything. It is the system that delivers everything we know about the universe, right?
Yes.
If it's on the electromagnetic spectrum, we can see it, and we can quantify it, we can learn from it. That light is delivering to us the data that is the information about the universe. And so that's a really great, that's perfectly appropriate and very good. And it relates to light again. There you go again.
Exactly.
So I heard, we were just talking before, and I don't want to jump the gun because there's no one, but I know, I just heard that you're working with somebody in life sciences, speaking of this, and there is perhaps a researcher at ASU that wants to kind of explore the idea of studying those nocturnal animals and those kinds of things, like as a test bed, as a lab for where those things come together, the light and the animals and their nocturnal life and how that works, right? So
yes, and in fact, the people who are in that field and study that field are very well aware of what's happening with a lot of species around the world because of the problem with excessive light at night. There are more and more research papers coming out all the time suggesting that we indeed have some problems on our hands. And one of the stories I like to tell during my presentations sometimes, which finally gets people's attention, is blue agave is pollinated by long-nosed bats.
right.
And that is now a threatened species because of excessive artificial light at night. And blue agave is needed to make tequila. So sometimes I tell people, when the world runs out of tequila, then they'll finally realize we have a little bit of a problem.
Get it.
And so, but the thing is, that's just one small example of what's happening to our ecosystems because of the excessive light at night.
You're right. I'm going to add another thing. I think you probably know, and some of our viewers know, I have this really deep interest in cultural astronomy, how other people have sort of embedded night sky, the movement of the stars, in their material cultures or in their oral cultures, in their art. And it's very, very difficult for us living today because most of us live in big communities, most of us live in big metropolitan areas, to even understand what ancient cultures saw, right? Mm-hmm. We don't see the same thing. And there are people, I run into people every day that have never seen that sort of line of the Milky Way. They've never been in a place where they can see it. We do a program every year with our incoming freshmen in some dark skies outside of Payson, Arizona, kind of near Phoenix, Arizona. And every single year there's 30 or 40 students that have never seen the Milky Way. They're seeing something that's just so close or so, was so available to ancient cultures, and they're seeing it for the first time. So I applaud what you do here. I think you're right. I think it has an impact on us physiologically, and it's obviously impacting the animal species, but it also, I think there's something we are missing as humans when we sort of get away from, when we can't be in that environment that our ancient ancestors just basically knew every night. And so I think that's part of our challenge.
Yeah, and when you talk about those ancient cultures, that's one segment of our facility is going to be devoted to archaeoastronomy.
Yep.
And as I'm sure you know, Rick, there are many examples of that in the Southwest.
Absolutely.
And actually all over the world.
Right.
But we have some tremendous examples here in the Southwest at Chaco Canyon and the Verde River site, and others that show how the ancient cultures were able to figure out when to plant, when there's the equinox, when there's a solstice, and there are many different examples of how they did it, whether using the sun dagger or light coming between rocks and hitting something.
Horizon rising.
It's actually quite amazing.
It is, and there's groups of people that study that. I am a member of an organization called Society for Cultural Astronomy in the American Southwest. It's exactly what you said. And one of our members is Ed Krupp. He's you might know him. He's the director of the Griffith Observatory in Hollywood, right? And he studies this kind of thing too. And we were kind of having a conversation one time. He says, we need to stop looking for cultures that embed astronomy in their culture. We need to look for some that don't, right? It's pretty much everybody. Every time you look around, every time you can investigate and understand these ancient cultures, there was always a very strong, very visceral connection to the night sky, to the stars, to the movement of planets, the sun and the seasons, as you kind of described. And so I think that's really important. That's an important mission that we all have,
yes,
and we all need to make sure that everybody in the world has access to that. So,
absolutely.
So that's really great. Okay, tell me about your timing. And I'm not ashamed to say that it's you're also fundraising, right? So there's a part of this is sort of pulling enough funds together to get your building off the ground. How are you doing it?
Well, it's a 22,000 square foot facility. It's a $25 million project,
and it's right here on this plaza,
right here.
Right.
And we've just in the past year we've raised about $8.5 million.
Okay.
And so we're making great progress. Of course, we have a ways to go.
Sure.
But we're very optimistic and very excited about what we're going to build, how we're going to work with ASU in several different ways, and we just need to get to a point where we can put a shovel in the ground.
And I would add the local school system, and everybody benefits. So applause to the people of Fountain Hills to see this vision, and you guys to put it together. And we really wish you the best of luck.
Yeah. Well, as a matter of fact, we're going to town council this Tuesday evening coming up, and that's when we will seek to have approval of our site plan as well as our facility design.
Good.
So once that takes place, then we go through a permitting process, and we'll be, at least from a design standpoint, ready to put a shovel in the ground early next year. But of course, we need to be funding ready.
Need to do that other detail.
We need that other detail. We need to be funding ready.
Yeah, I have a good feeling about it, and really, I think it's an asset for the entire community. And actually, that's the message you need to get out, right? This is not just Fountain Hills; it's for the entire valley. And as we've made the case, right, this is the place you're going to go see your dark skies. And
can't wait.
I think
Can't wait.
All right. Well, thank you very much. And I'm going to just kind of start to wrap up here. I just got some more announcements to make and some things to talk about. But I just really appreciate Joe, having you here and pulling this thing together with me. I think this is Joe was in my office, I think, probably about 5-6 weeks ago, and we were talking about other things and we were doing all that kind of stuff. And then I said, Joe, do you know about Observe the Moon Night and all this stuff? And he was a quick study. He said, yep, okay, and that's a good idea, and that's a Saturday, and we should put that together. And so helped me make the connections, and now we're here. So.
Well, Rick, a lot of credit goes to you and your staff.
Oh,
so
thank you.
We really appreciate it.
I've got the greatest staff. That's really super cool. Thank you. All right, everybody. So we've kind of done the segments we had planned to do. I'm just going to one more time just welcome everybody that was able to participate tonight. I thank very much the Lunar Reconnaissance Orbiter Camera and Chris Luna. I hadn't met Chris Luna until tonight, but I knew he was over at that center, and that was really super cool. Thank you for that. Scott Adams, your photography is amazing, and thanks for sharing that with us. And more power to you. You've got an amazing, amazing hobby. When I retire, I'm going to be doing the same thing. I haven't told my wife yet, but when I retire, I'm going to be doing the same thing. And then the people of Fountain Hills that put this together, made this thing happen, that know the urgency of saving our night skies. You guys are to be applauded for sure. So it was fun to be here, fun to be in a group of people and have the community around us. Some things coming up. I just have some announcements of some things going on. This is October the 1st, and we can check International Observe the Moon Night off our list because it was a success and we've done this. Next Wednesday night, we do have one of those virtual night sky broadcasts, and that happens at Arizona State University. You'll see me again. I'm the host of that program, and many students who are actually talking about, I think I mentioned it before, a special project to send a spectrometer to Europa, a moon of Jupiter. And so if you're wondering what a spectrometer is and you're wondering why Europa, we're going to explain it all to you next Wednesday night. The day after that, at the Arizona State University campus, we have a new Discoveries lecture series and two professors, Evan Scanapiecco, and I'm sorry, I forgot the other name. We're going to be talking about sort of a halo around galaxies and what they're discovering and how they're discovering that and what that looks like. On October the 15th, there is a very special day on the Arizona State University campus in and around my building from 10 o'clock to 2 o'clock. We call it EC Day, which means Earth and Space Exploration Day, and that's absolutely free. You'll meet a whole bunch of researchers. You'll see a whole bunch of things going on. There's a whole bunch of students that will be showing you their work, and we're using our immersive theater to give people a little fly around the galaxy several times during that particular program. So if you want to come out and visit us on campus, October 15th, 10 o'clock to 11 o'clock. And those are the big announcements for now. So again, my name is Rick Alling. I'm a manager of community outreach for the School of Earth and Space Exploration. With me is Alex Blanche. Thank you very much for doing the technical in the background and handling the camera. You're amazing. Maitreya is helping us do telescopes and kind of getting things organized and working with the public out there. And it's been a great experience. I love being here today. We are going to just continue to show you a live shot of the moon until about 8:30, and then we will start to close. We will then close our program, but I want to thank everybody that joined us virtually, and I thank everybody that joined us on site, and I hope you've had a really good night tonight. Thank you very much, everybody. I'm going to say good night. We'll be showing you the moon for another 10 minutes until 8:30. Thank you.